Hi everyone, today's notes will be section 1.1 and we're going to go over some key features of functions. So the first vocabulary word we have here is a relation. A relation is basically any ordered pair or any graph that you may have. In a relation, your x values can have more than one y value. A function is going to be a special type of relation. It is a relation for which every x value has exactly one y value. So if I went ahead and made a table of values for a function versus a relation, you'll see the difference. So a function, every single x can only have one y. But in a relation, our x values can actually have more than one y. So I can have the point -1, 2, and I can also have the point -1, 3. So a function has one y value for every x value. The next word we are going to go over is domain, and that is super important because you will be finding domain of functions throughout all of Algebra 2. So a quick and easy definition for domain is going to be the x values of the function. So when you're trying to find the domain of a graph, you want to make sure you're reading the graph from left to right. Range is also a key word that you need to know, and we're going to be using that throughout Algebra 2. So range refers to the y values of the function. So when you're looking for the range of a function, you want to look at the lowest value or the lowest point and think about where is the graph going? Is it forever going up or is it stopping somewhere? The vertical line test is a special test to help us determine if a graph represents a function. So if you take a vertical line and it intersects at more than one point on your graph, then it is not a function. So we have an example of a function and not a function. So this first graph, if I put a vertical line here, it is only going to intersect my graph once. Versus if I put a vertical line at the second graph, it crosses my graph twice. So that's not going to be a function. You could also write out a table of values and notice that on this first graph, we don't have any x's repeating. But on the second graph, we see that we have a point at 2, 2, as well as 2, -2. So because you have the same x with different y's, this is not a function. So I want you to look at these next three examples and use the vertical line test to determine if the graph represents a function. So pause the video really quickly and answer whether it represents a function or not. All right, let's go over these three examples. So the first one here, you should have gotten yes, this is a function. For the second one, you should have gotten no, not a function. If we check with the vertical line test, right here, it intersects my graph twice. And also right here, it intersects twice. And the last one, yes, this is a function. So in this chart, there are a couple key things to note. We use set notation and interval notation when we're writing out domain and range. You do need to know how to write domain and range in both ways, but personally, I prefer interval notation. A couple things to note here. We use parentheses when the value is not included. And sometimes in a graph, you will see an open circle, and that's how you know the value is not included. We're going to use brackets when the value is included. And sometimes you'll see that on a graph with a closed circle. When we are talking about infinity, we always use parentheses. The notation will make more sense when we get to the examples on the next page. So in this example, we need to identify the domain and range. So remember, domain refers to your x's. So you're going to read your graph from left to right. You're thinking about where is the graph going on this left side? Is it continuing or is it stopping at the -5? And you're thinking, where is your graph going on the right side? Is it continuing or is it stopping right here at this point? So since we have arrows at the end of our V here, we know that our domain is going to be -infinity to +infinity. This means that the graph is going forever to the left and forever to the right. Another way you can write this is by using this fancy R, and this just means all real numbers. Again, it's just telling us that the graph is never ending going to the left and going to the right. When we're talking about range, we're looking at our y's. So we're looking at the lowest point of the graph and the highest point of the graph. So my V starts right here, and you want to look at where that is on the y-axis. So it's going to start at -4, and we're putting a bracket there because it is part of the V. Now we're thinking, what happens to the graph after -4? Is it stopping somewhere above it? Is it going forever up? And we notice that we have the arrows, so that means it's going forever up, which means it's going towards +infinity. Another way that you can write this is y is greater than or equal to -4. That tells me that -4 is my lowest value on my graph, and everything else is above it. Before I get to the second one, I'm going to go ahead and explain the bottom two. So going down to the zigzag one here. Again, domain refers to your x's. So you're reading the graph from left to right, thinking about what happens on the left end, what happens on the right end. Again, I see arrows on both sides, which means it's going from -infinity to +infinity. Or I can say all real numbers. It's never ending. Range is referring to the y's. So you're thinking about, is there a lowest point? Is there a highest point? Or is my graph going on forever? This is where some students get confused. We see that there is a low point and a high point, but we have to remember that these arrows are continuing and they're going beyond those points. So really, my range is negative infinity to positive infinity. This graph is going forever down and it's going forever up. It's never stopping. Or we can write all real numbers. So even though you have points in between, when you're looking at domain and range, make sure you're focusing on the extremities or where the ends of your graphs are going. All right, this one here, so let's start with domain, which refers to our x's. We're thinking, where is the graph going on the left end? Where is it going on the right end? So on the left side, I see an arrow, which means it's going to continue to negative infinity. On the right side, I also see an arrow. I know the arrow is going down, but you guys need to think about right or left. We're not really thinking about up or down. So I know this is going down, but it's also going to the right, and that's what we're focused on for domain. So it's going forever right, or all real numbers. Range is talking about our y's. So we always want to start with what's happening on the lowest end and then what's happening at the highest point. So our graph is going down. They have arrows pointing down, which means it's going towards negative infinity, and it has a stopping point right at 3 on your y-axis with the bracket because it's actually part of your v. We can write this as y is less than or equal to negative 3 because my graph is below 3. Sorry, not negative 3, I meant positive 3. All right, let's get to the second one right here that has 2 pieces. So still thinking the same thing. Domain means our x's. So we're reading our graph from left, what's happening on the left side, what's happening on the right side. So I know there's 2 pieces here, but if you're looking at the graph as a whole from left to right, there really is no gap on the x-axis. So again, if you're looking at the x-axis, think about if you're walking along the x-axis, there's nowhere on this x-axis that I'm going to stop and I'm not going to have a piece of my graph. So on the left end, the graph is going forever to negative infinity. On my right end, it's going up, but it's also going up and to the right. Since this open and closed circle is on the same x value, they're both at -1, they kind of cancel each other out. So if it had just an open circle, that means it's not included. But since it has a closed circle on the other graph, that means it actually is included. So there's no gapping happening on the x-axis. Remember, you can also write this as all real numbers. Range, we're going to look at the y's. So we're looking at the graph up and down. We notice that the lowest value of my graph is at -3. And the graph is continuing up. So that's going to go to positive infinity. We can write this as y is greater than or equal to -3. So what I would like you to do right now is pause the video and go ahead and try these 2 on your own, and then I'll go over the answers. All right, hopefully you guys tried these 2, so let's go over the answer. For this first one, your domain should have been negative infinity to positive infinity, and your range should have been 3 to positive. For this next one here, domain is negative infinity to positive infinity. The range is negative infinity to -1 with the bracket. All right, this next example here actually goes along with section 1.2. So we're thinking about transformations. Remember, transformations from geometry meant we're shifting things left and right, we're reflecting things, we're rotating. We don't necessarily think of rotating so much when we're in Algebra 2. We focus more on reflections and translation, so moving up, down, left, and right. This example is asking us to describe the transformations necessary to transform our parent function, which is this blue graph here, onto the new function, which is the dotted line. So this here is referred to the parent function. And if we want to get really specific, this is the parent function of x squared, of a quadratic, because it starts at 0, 0, and it's that U shape, opens up, it's positive, that's your parent function. So you're describing how do we get that parent function onto the green dotted line. So the first thing I could say is that I need to do a reflection across the x-axis. So that is going to get my U to be upside down. And then I still need to shift my vertex over to the left. So I'm going to say translate left 3 units. And that should land my parent function onto my new function. Same idea for the second one. So here, if you remember way back in Algebra 1, a V represents your absolute value. So this is the parent function for an absolute value graph. That's with the bars. So we're thinking, how do we get my parent function onto my new function? So I notice that I definitely need to translate my graph up 3 units. Now notice that my green dotted line graph is wider than my parent function. If something is getting wider, we're going to call that a compression. For right now, we don't need to specify what the compression is. When you have equations, you'll be able to specify, for example, compression by a factor of 1/2 or a compression by a factor of 1/3. When you're just looking at the graph, you don't need to worry about what the compression factor is. All right, numbers 3 and 4. So here we don't have the parent function graphed, but you can go ahead on your copy and add in the parent function. And our parent function is just going to start at 0, 0, opening up. So now we're describing how do I get that parent function onto the new function. So in number 3 here, it looks like I just need to translate my parent function up 3 units. For number 4, let me put in my parent function really quickly. I might want to start with the reflection across the x-axis. Then I might need to translate down 1 unit and left 2 units. All right, so that is section 1.2, just thinking about how to transform your parent function to new graphs.